Hi, welcome to es201 Computer Techniques. This is the online section, FX1 for 2017. I'm Rourke Peterson. I'll be the instructor for this class. And what I wanted to do in this first introductory video is just make sure that we're all on the same page of where to find all the materials that you need for the class, when the due dates are, and everything. So really all that information is on the syllabus. So what I recommend is going over to Blackboard and taking a look at that. And I'll just do a quick perusal through there with you. So if we go over to Blackboard, the first thing you should be looking at, if you haven't already, is to go over and look at the syllabus. And so that's going to be the left-hand link that you have over here on the left. It's taking a second here to open, but there we go. And you should see at the top, you should see the syllabus. Your syllabus is the first one listed. It's a little bit different than the other one, so make sure that you select that one. I'll go ahead and open this as well, because I just want to point out a couple of important things if you haven't already gone through this and looked at it. Okay, so let's go ahead and make this a little bit bigger so we can go ahead and see some of the important parts of this. Okay, so one of the things to note is that, as you've heard, there's no lab on Friday. So you should be attending one of the labs on Tuesday, Wednesday, and Thursday. Most of you have let me know which lab you're going to be in, but make sure that you let me know so that we can go ahead and give you full credit. The next thing is to look through. There's some what we call preparation, which are the Zybook activities, and I'll show you those under the course content. So make sure you've registered and gotten your Zybook. As I say, I'll go ahead and record classes and be posting them online just as I have done with this one here. You need to attend the in-person lab, and so there's some information here on the second page about the lab. And as I said, you need to be attending lab on either Tuesday, Wednesday, or Thursday. Homeworks are completed within the Zybook, and I'll show you where that is as well. And so that's the last component there. We'll also have a final exam during the final exam period. And so I ask that you take this during the regularly scheduled one for the face-to-face class, which is December 14th, 10:15 to 12:15. If for some reason you can't make this because maybe you have another class at the same time, let me know ahead of time and we'll try to schedule another alternative time period for you to take the exam. But the preferred time is that you come in person on December 14th, 10:15 to go ahead and take the exam. Here you go ahead and see the course distribution about how everything is weighted so you can determine what you need to do to accomplish a particular grade for the class. So the last thing I want to do is just go down and show you the schedule here so you understand the due date since you won't be attending the face-to-face class. All the class dates are listed on the left-hand side of the column here. And then you will see there's homework due and Zybook chapters due, and sometimes they're the same day and sometimes they're different days. So for example, if you look at Zybook chapter 1, you'll realize that's due on 8/31, which was Thursday of this week. I'm going to go ahead and give you an extension until next Tuesday. I recognize everyone didn't necessarily get into the class on time and register. So actually the due date for this now is actually going to be 9/5, the next line down. On 9/5, which is next Tuesday, the first homework assignment is due. That's listed as the last section in the Zybook. I'll show you that here in just a moment. And so that's going to be due on September 5th. And then you'll realize the Chapter 2 Zybook activities are going to be due on the 7th of September, etc. So you can go ahead and find out when all those due dates are there. If you look a little further down the schedule, you will see that there's going to be some times where there's homework Zybook activities due on both Tuesday and Thursday. The time that these are due is at the beginning of the face-to-face class, so they're going to be due at 9:45 in the morning each time that you've done it. At that point, we'll freeze any further submissions that we have. So make sure you turn in both homework and Zybook activities by 9:45. If you have any questions about that, please let me know. So the next thing you do is register with Zybooks, and the easiest way to do that, if you go back to Blackboard, and I'll go ahead and go back there, if we just go over into your course content, and then you'll see under week 1, my content's a little slow here, okay, and click under week 1, which is the week that we're in here. The very first thing that you'll see listed will be the Zybook reading activity. If you go ahead and click on that link, that will go ahead and take you directly to the Zybook site so you can register for the first time. On the syllabus, you'll see that the class name that you want to enter. So when you get to the Zybook, you're going to see something that looks like this once you've got registered for the class for our textbook. And if you go ahead and expand out, this is chapter 1. And so that's what we'll be doing this week. And if you look at the various chapters of that, there we go. At the very bottom of this is going to be where the homework assignment is. It is section 113 this week. And so that's where you're going to go ahead and submit your homework. And there will be a section at the very end of each chapter, which is where your homework. And you submit it through the Zybook as well. So these are the activities you need to do 1 through 12, and then you need to do the homework. Those are two separate things, although they're both within the Zybook. So, okay, well, if you have any questions about the syllabus or the way the class is going to operate, please feel free to either come see me or send me an email, and we can go ahead and answer that. There's a little bit of introductory material here. It's the same as we had last year, so I'm going to go ahead and cut over to that video now and show you just a couple of the introductory concepts. Otherwise, good luck this semester, and please come and see me or send me an email if you have any questions. All right, good luck. Just a little bit about myself. As I said, my name is Rourke Peterson. I'm an associate professor of mechanical engineering. And my research areas, I do work with cold climate heat and mass transfer. I also do some work with renewable energy integration, particularly in terms of remote communities in Alaska. And then I also do some volcanic ash dispersion modeling, and this is where actually most of my programming experience comes from. There's a program called POP that I wrote and is used by VADAPT, which is a private company spin-off here out of UAF. That's a component of that program. Let me just mention a little bit the course goals, because it's important to kind of put this course in context so you understand what we're trying to accomplish. We want you to gain an understanding of basic computer skills, and I really want to point out basic here. This is not a computer science class. This is just to give you some general tools that you as an engineer would be able to use. And so you're not going to be writing really large, complicated projects. You're going to be writing fairly simple programs. I want you to develop a working knowledge of C++ and MATLAB. And what I mean a working knowledge, meaning you can write a small program, or you can take a larger program and modify it. Again, we're not going to be writing large projects. I just want you to have a basic working knowledge. It's just yet another tool on your engineering tool belt. And then the last thing, which may not be quite as obvious, but is an important learning goal, is you're going to learn algorithmic approaches to analyzing and solving problems. It's kind of an important engineering tool to have, and knowing how to, when you want to accomplish a particular goal, how to get it when using numerical skills. And we'll be doing this throughout the semester as well. Okay, let me just mention a little bit about the learning process and the approach I'll be taking in this class. We're going to be doing a very gradual approach, and so if the class seems fairly straightforward at first, particularly if you've had any previous programming experience, just enjoy it. I sure don't want to do a really rough, steep increase here where we would be dropping off a lot of people that may not have a lot of programming experience. So we'll be doing sort of a gradual ascent, and then we'll be taking breaks as we move through here so that you won't get exhausted as we move through the class. So this is not going to be a particularly arduous class. It may not be the most difficult class you're taking this semester, but it might be depending on your previous programming experience. My goal at the end of this is to have everybody up at the same level, depending on where you started. Some people will start a little further down than other people, but at the end we're all going to be up at the same point. So that's kind of the ultimate learning goal that I have. We mentioned just a little bit about C and C++. I sort of use those terms interchangeably to let you know the difference. This is the first programming language we'll be looking at. We'll be using this in the first half of it. And the analogy I like to use is that C is sort of like this race car that I show in this picture here. In fact, if you wanted to build a really fast car, what you would do is just put the minimum things that you need. So for example, you might put a frame on here. You're going to put some wheels on there as well. Obviously, you're going to need an engine, and then you want a driver, so you're going to put on a seat. And then that's going to be it. You're not going to add anything more. To make this as fast as possible, you're not going to have any seat belts, you're not going to have any airbags, you're not going to have any stereo on it. It's just going to be a stripped down version. Very fast, very lightweight. The analogy, this is like writing programs in C or C++. You're writing very fast, efficient programs that can be put on very small memory devices as well, particularly in this Internet of Things age where almost everything has a computer. It's nice to write really small, fast, efficient programs that don't take much power. So that's what we're going to be doing, and that's in contrast to MATLAB, which we'll look at in the second half, which is more like the Lexus that has all the bells and whistles on it. It can do everything. It can do long distances, short distances, drive slow, drive fast, drive commuting, but it's also much more expensive, and it's also just carrying a lot of stuff around that you don't always need. So sometimes it's nice to just jump in your Lexus, but sometimes if you want to really go fast, you're going to want to build it with a race car. We're going to be looking at both. Let me explain the difference between C and C++. C++ is a superset of C, meaning that everything that's in the C programming language is contained in the C++ language, but C++ has some additions to it as well. And what happened was C was developed, and it's actually still, I believe, the most popular programming language, but there was a couple things missing in it. And after a while, some people decided, let's go ahead and add these extra things to it, and they called it C++. A little bit about the name. There's not a C+ language that occurred in between the two. This is shorthand notation. This plus plus we'll see for adding one to a variable. So for example, if I had a variable called Joe and it currently had a value of 5, if I put Joe plus plus, that 5 would become 6. And so that's kind of the idea. We just added on a couple things to the C language. So that's why it's called C++. Some of the differences in between it, there's a couple additional keywords in C++ that are not in C. These are special words that mean to do particular things. We'll be looking at those throughout the semester. The include statements are slightly different when you include these header files, and you'll see that. And the most important thing that you may hear about is that C++ has classes or objects. It's an object-oriented language, whereas C is not an object-oriented language. We'll look a little bit at classes and objects at the end of this first part of the class. We won't be doing too much, but it's kind of nice to understand what it is when someone says a language is object-oriented. All right. Let me also just mention a little bit about templates. So if you think back to maybe like grade school or something, whenever you had a writing assignment, the teacher would say, let's do a writing assignment. You'd pull out a piece of paper, and maybe you'd go ahead and put your name over here, and then you'd put the date over here, and then you'd begin the writing assignment. The writing assignment would be different every time, but this template with your name on the right, your date on the left, and the top on this piece of paper here was sort of done the same way every time. And we're going to see we're going to have a template for C++ programs as well. And they're going to kind of look something like this, where at the top we're going to have a series of comments. And that's what these green lines are showing, which will have your name, the homework assignment name, and for example, what the date is. And then you're going to have a couple things here that's like the date and name on the piece of paper. You're going to have this include statement. You're going to have this statement that says using namespace std. We'll talk about that a little bit more. Std is shorthand for standard. And then you're going to have this int main with a couple curly brackets. This return 0. And you're going to have this every time that you write a program. And all of your program is going to go in here. You might include a couple extra include statements in there. But this is going to be this general template that we're going to be adding in every time. And that's just sort of some overhead you need to do whenever you need to write a program. Let me talk about the first couple tools that you'll be using this week in lab. And they're called cout and cin. And these are actually objects. These are actually called global instances of an object. But we'll be looking at it. And I like to think of cout and cin as kind of a Swiss Army knife, in that they're a tool that has many little, or a device that has many different tools on it, right? It has a blade and a bottle opener and a screwdriver on here as well. And so cout has various things it can do. In our language, this is called methods. And we'll be looking at several of those. So cout is what's considered an object. And it's of type OStream. And so OStream is shorthand for output stream. And the way I like to think of it is this OStream is, for example, like the word pocket knife. Right? And so if I said I have a pocket knife, it may be a Swiss Army knife and it may not. So pocket knife is sort of a superset. So cout is of type OStream, but cout is like the Swiss Army knife, and it's a type of object. It's a type of OStream object that we have. And so I could have a pocket knife that's not a Swiss Army knife, and so I could have an OStream that is not cout or cin. And so a couple of the operators we'll look at are these are called stream operators, which are these two angle brackets this way. The first one are used for cout, and the next one is cin. And this is how I go ahead and write output to the screen and input to the screen. And you can probably guess that cout outputs material to the screen, cin takes input from the screen. So let's just talk about stream output. I'll look at cout in particular. And we'll look at cin as well when you're in lab. This is how you go ahead and write just the word hello there to the screen. You use cout, and then you're going to use this called stream operator, and then the word hello out, hello there, which is called a string literal, because I mean literally take the words hello there, and then go ahead and send them to the method cout. Cout writes that to the screen. So that's how you go ahead and write the word hello there to the screen. If I had a variable called name, for example, I could go ahead and send that to cout. It would find out what information is stored in name and write that to the screen. And this being a variable, I could change it. I might set it to Rorik, then I might set it to Joe, and then I could set it to Catherine or anything like that. I can concatenate things various together. So if I wanted to print to the screen, hello there, Rorik, there would be hello there, and then I would go ahead and concatenate or put another string operator and the variable name, and it would write hello there, and then whatever is stored in name. That way I could go ahead and change this message every time within my program. Then there's also a couple other special characters that I can do. This ENDL is shorthand for end line. This is like the enter key or the return key on your keyboard, and it just goes into the next line. So this would write hello there, whatever is stored in name, and then go to the next line. In terms of stream input, that is done with cin. And the stream operators are turned in the opposite direction. So now what this is going to do is it's going to read from the screen whatever I type and store it in the variable name. So if I wrote this in my program, it would wait in the screen for me to type something and hit enter or space, and it would stick it in the variable name. This would be an error because here this is what I'm trying to do is say whatever I type in the screen, store literally in the word Rorik, but if I type Joe, it isn't Rorik, and so that wouldn't work. So this would actually be an error in my program. I can go ahead and do, just like with stream output, I can go ahead and concatenate several things. So if I had cin, first name, last name, and on the screen if I was to write Rorik, and then with a space, and then Peterson into the computer terminal, it would put Rorik into first name, and then Peterson into last name. There will also be some quizzes that take place in the in-class lecture, and you'll go ahead and see these in these videos as well. They're good practice. They're going to be a lot of what the exams will look like, so I'd encourage when I go through these quiz questions that you go ahead and participate in them. And so, for example, hopefully here you could answer what this answer would be, and the correct answer to that would be B. Okay, well, that's it for this introductory video. Please go ahead and read the syllabus and look through Blackboard, and register for the zybook site and start in on Chapter 1 assignment that is due in a couple days. All right, I will see you later.